Have you ever seen something disappear into thin air without a drop of liquid? It's a fascinating phenomenon that seems almost otherworldly. But what if I told you that this magical effect is actually a simple scientific process? That's what dry ice does. Dry ice is the solid form of carbon dioxide, and it has some pretty amazing properties. It's like magic, but it's actually science. When dry ice is exposed to room temperature, it doesn't melt into a liquid like regular ice. Dry ice doesn't melt like regular ice. Instead, it transforms directly from a solid to a gas in a process called sublimation. Instead, it goes through a cool process called sublimation. This means it skips the liquid phase entirely, creating that eerie, fog-like smoke. Dry ice looks like regular ice, but it's much colder and disappears without getting things wet. This makes it perfect for situations where you need to keep things dry and cold. This makes it super useful for all sorts of things, from keeping things cold to creating spooky effects. Whether it's for shipping perishable goods or adding a dramatic flair to a Halloween party, dry ice is incredibly versatile. So what exactly is dry ice? You might have seen it in science experiments or even in spooky Halloween displays, but have you ever wondered what it really is? Get this, it's just frozen carbon dioxide. Yes, the same carbon dioxide that's in the bubbles of your soda, you know, the gas we breathe out and plants use to make food. It's all around us, playing a crucial role in the cycle of life. When carbon dioxide gets really cold, it freezes and turns into dry ice. This happens at a chilling -78.5 degrees Celsius. We can't see carbon dioxide gas in the air, it's invisible to the naked eye just floating around us. But when it's frozen into dry ice, we can hold it in our hands, with gloves on of course. It's used in shipping perishable items, and even in special effects. It's way too cold to touch directly. Touching it without protection can cause frostbite almost instantly, so always handle it with care. Now let's talk about sublimation. It's like a shortcut on a board game. Instead of going from solid, ice, to liquid, water, dry ice skips the liquid step and goes straight from solid, dry ice, to gas, carbon dioxide, when it warms up. Imagine a caterpillar turning straight into a butterfly without becoming a chrysalis first. That's kind of what sublimation is like. Pretty neat, right? Pressure and the sublimation secret. But why does dry ice sublimate instead of melt? It all comes down to pressure. You see, everything around us, including air, has pressure. And pressure plays a big role in whether something melts or sublimates. Dry ice really likes to be a gas, so at normal air pressure it turns straight into carbon dioxide gas without ever becoming a liquid. Cool uses for a cool substance. Because dry ice is so unique, we can use it for some really cool stuff. One of the most fascinating things about dry ice is its ability to sublimate, which means it turns directly from a solid into a gas without becoming liquid first. This property makes it perfect for creating dramatic visual effects. Imagine a science experiment where you can make a beaker overflow with a thick, mysterious fog. It's like magic, but it's all science. It's great for keeping food and medicine cold because it keeps things much colder than regular ice. This is especially useful for transporting perishable items over long distances. For instance, when you need to ship seafood or ice cream, dry ice ensures that these items remain frozen until they reach their destination. Similarly, in the medical field, dry ice is indispensable for preserving temperature-sensitive medications and vaccines, ensuring they remain effective. It's also used to create spooky fog effects in movies and for Halloween. The dense white fog that dry ice produces can transform any setting into a haunted house or a mystical forest. Filmmakers and event organizers love using dry ice because it adds an element of mystery and excitement. Whether it's a thrilling scene in a blockbuster movie or a chilling Halloween party, dry ice fog never fails to impress. And scientists use dry ice for all sorts of experiments. In laboratories, dry ice is often used to conduct experiments that require extremely low temperatures. For example, it can be used to flash freeze biological samples, preserving them for future analysis. Additionally, dry ice is used in chemical reactions where precise temperature control is crucial. Its versatility makes it an invaluable tool in scientific research. Remember though, dry ice is extremely cold, so always handle it with care and with adult supervision. Direct contact with dry ice can cause severe frostbite, so it's important to use protective gloves and other safety gear. Always ensure that dry ice is used in well-ventilated areas to avoid the buildup of carbon dioxide gas, which can be hazardous in enclosed spaces. Science is all about exploring the wonders of the world around us, And dry ice is a perfect example of how amazing and surprising science can be. From its practical applications in everyday life to its role in scientific discovery, dry ice showcases the incredible possibilities that science offers. So next time you see that mysterious fog or enjoy a perfectly preserved treat, remember the cool science behind it?